My dear students, myself Suguna HG, Assistant Professor, GFGC and PG Center, Chintamani, Chikkaballapur District. In this video, we are going to discuss about the definition of asymptote, types of asymptotes, and how to find parallel asymptotes. First, let us define asymptote. An asymptote of a curve is a line such that the distance between the curve and the line approaches zero as one or both of the x or y coordinates tends to infinity. That means asymptote is nothing but a tangent to the curve at infinity. Either it is minus infinity or plus infinity. See, when you extend the curve in both the directions, it never meets that line. So it is approaching towards that line to zero, but it never meets. Those are called asymptotes. There are two types of asymptotes, parallel asymptotes and oblique asymptotes. Now in parallel asymptotes, we have the asymptote parallel to y-axis and asymptote parallel to x-axis. The asymptotes parallel to x-axis are nothing but the straight line x is equal to a, and also this is called as vertical asymptote. Then the straight line y is equal to b is called the asymptote parallel to x-axis, and we call this as the horizontal asymptote. Now see from the figure, y is equal to f of x is a curve, x is equal to a is a vertical line. See, if you extend this curve to infinity, it never touches this line. So the line x is equal to a approaches to the curve, but it never meets. So x is equal to a is a vertical asymptote, or we call it as an asymptote parallel to y-axis. And similarly, we have y is equal to b line, that is the horizontal asymptote. See, y is equal to b is also a tangent to the curve y is equal to f of x at infinity. See, extend this curve y is equal to f of x to infinity. It never ever touches the line y is equal to b. So y is equal to b is called an asymptote parallel to x-axis. Other than these two, we have the oblique asymptotes. They are nothing but slant lines like this. See, a line y is equal to mx plus c is said to be a oblique asymptote of the curve f of x. So an oblique asymptote is the line that neither horizontal nor vertical. So it gets very close as x goes to infinity, negative infinity or positive infinity. Even vice versa also, as y goes to infinity or negative infinity, it never touches the line y is equal to mx plus c. This is very close to this curve, but it never touches. So that is called as oblique asymptote. In this session, just we are going to find out the parallel asymptotes. Working rule to find parallel asymptotes. So the asymptotes parallel to x-axis are obtained by equating to zero the real linear factor in the coefficient of highest power of x. So the coefficient of highest power of x is equated to 0, and we find the parallel asymptote to x-axis. Similarly, the highest power of y's coefficient is equated to 0 and find the y-axis parallel asymptotes. So the asymptotes parallel to y-axis are obtained by equating the coefficient of highest power of y to 0. Now let us work out few problems based on these. First problem, find the asymptote parallel to the coordinate axis for the curve x square y square minus a square x square is equal to a square y square. The given equation we will take, that is x square y square minus a square x square is equal to a square y square. x square y square minus a square x square. Remove the common factor x square outside. So we get x square into y square minus a square is equal to a square y square. The coefficient of highest power of x is y square minus a square is equal to 0. This implies that y square is equal to a square and y is equal to plus or minus a. Now y is equal to plus or minus a. We have two asymptotes plus a and minus a parallel to x axis. So we have taken the coefficient of highest power of x, that is y square minus a square, equated to 0 and found y is equal to plus or minus a, that is the required asymptote parallel to x axis. Again take the same equation and rearrange the terms. Transfer y squares to one side. So we get x square y square minus a square y square is equal to a square x square. So rewriting the given equation, we get x square y square minus a square y square is equal to a square x square. Now what is the common factor among these two? Y square. So we will remove y square outside. Then we get x square minus a square inside the bracket, which is equal to a square x square. Now what is the coefficient of y square? See, y square is the highest power of y present in this equation. So the coefficient of this is x square minus a square. Now let us take this x square minus a square, that is the coefficient of highest power of y, and equate that to 0. So x square minus a square is equal to 0 implies x is equal to plus or minus a. So plus or minus a are the two asymptotes parallel to y-axis. Hence the asymptotes parallel to both the coordinate axes are x is equal to plus or minus a and y is equal to plus or minus a. Here we have 4 asymptotes. Then we will take up another problem. Find the asymptotes parallel to the coordinate axis for the curve y cube minus x square into y is equal to x square plus 1. Solution. Let us take the given equation, that is y cube minus x cube y is equal to x square plus 1. Transfer the terms to LHS. So we get y cube minus x square y minus x square minus 1 is equal to 0. So we have to write it in the form of linear equation. So a highest power to lowest power, like this we have to arrange the terms. Hence in this equation, see, x square common is there in these two terms. So let us remove them outside. Y cube minus of y plus 1 into x square minus 1 is equal to 0. Now you observe here the y plus 1 we have, that is the coefficient of x square. Y plus 1 is the coefficient of x square. So x square is the highest power of x present in this equation. Hence equate y plus 1 is equal to 0, that is negative sign, minus y plus 1 is equal to 0. Hence this implies that y plus 1 is equal to 0 and y is equal to minus 1. Hence y is equal to minus 1 is an asymptote parallel to x-axis. When we equate the coefficient of highest power of x, that is x square's coefficient minus of y plus 1 is equal to 0, then we get y is equal to minus 1. So y is equal to minus 1 is an asymptote parallel to x-axis. Now coming to the highest powers of y. So that is y cube. What is the coefficient of y cube? 1. So it is a constant. Y cube's coefficient is 1. It is a constant. Therefore, there is no asymptote parallel to y-axis. See, since the y cube's coefficient is 1, it is a constant. So it has no asymptotes parallel to y-axis. One more problem we will work out. Find the asymptotes parallel to the coordinate axis of the curve a square by x square plus b square by y square is equal to 1. We can rewrite the given equation as a linear equation, that is, take the LCM x square y square, then you will get y square a square plus x square b square by x square y square is equal to 1. Cross multiply this and equate this to 0. So we get y square a square plus b square x square minus x square y square is equal to 0. See, by rewriting this equation into a linear form, we get like this. Now see, among these x square is common, so remove x square outside. Then we get y square a square plus b square minus y square into x square is equal to 0. Now in this equation, the highest power of x is x square, highest power of y is y square. Now let us take the coefficient of x square, that is b square minus y square. This is the coefficient of highest power of x, and let us equate this to 0. So we get b square minus y square is equal to 0, which implies that y square is equal to b square. Hence further this implies that y is equal to square root of b square, that is plus or minus b. Hence we have two asymptotes, y is equal to plus b and y is equal to minus b parallel to x axis. So we have two asymptotes parallel to x axis. And also the given equation can be written as y square a square plus b square x square minus x square y square is equal to 0. It can be written as a square minus x square into y square. See, we have removed the y square common factor among these two terms. Then we get a square minus x square into y square plus b square x square as it is. Now even in this equation, the highest powers of y is y square, highest powers of x is x square. Let us equate highest power of y to 0. That is a square minus x square is equal to 0. So which implies x square is equal to a square and x is equal to root of a square, that is plus or minus a. Now x is equal to plus or minus a are the asymptotes parallel to y axis. So even this curve has 4 asymptotes, that is x is equal to plus or minus a and y is equal to plus or minus b. Thank you.